Well, aloha, and thank you for having me today to close out Local Mocosec. I'm super excited to be here, like I'm most speakers. I want to start by saying that I hope everyone is doing safe, is doing okay with everything going on in this year. And I'm looking forward to being able to join Local Mocosec in person next time we join. So I'm thrilled to be here. As introduced, I used to lead a one of the most critical functions I think at Microsoft, which is the vulnerability response team. This is the team that's at the front edge of receiving and responding to security vulnerabilities at Microsoft. I have since moved. That's why you see the title as threat intelligence lead. But I'm speaking here about my old team, and I'm super thrilled to talk about a topic that I'm super passionate about and excited because I think is one of the core things that as security professionals we want to try to tackle, and that is getting away from security whack-a-mole. And for those of you that may not be familiar with the game whack-a-mole, like I wasn't when I first came to the United States, that whack-a-mole was not a game I was familiar with. Um, it's a game basically where you're trying to whack moles that come out of the arcade machine that you're seeing in front of you. And the more that you succeed in the game, the faster the moles come out, and the more of them that come out at the same time. And so the objective is to whack these moles as soon as possible. And of course, if you've been in security, I'm sure that you have heard this term, playing security whack-a-mole. It was one of those things that at first shocked me because it's how I came to know the game whack-a-mole. But it's certainly very, very true that it's easy for us to get caught up in playing security whack-a-mole over and over again. And the reasons why varied, but I think when we look at it, it can be a lot of fun, just like the game. There can be a lot of satisfaction that comes out of either fixing a bug or responding to an alert that was particularly impactful, or taking action on some particular threat, or playing or identifying and taking action on a particular IOC. But ultimately, you're basically moving the needle a little bit forward when you're taking those actions and repeating them over and over again. And eventually, it can get to be very, very exhausting when you're doing the same thing. You fix this one security bug, and then you have five waiting on you that you have to basically repeat the process on, or you knock out an alert, and you have same type of alert waiting for you on other systems or on other devices. And so eventually it can get really exhausting, it can get draining, and it leads to, as we know, exhaustion in the field. And some people end up leaving because they get tired of playing the same thing over and over again. And I do realize I didn't choose the best picture to show exhaustion, but I couldn't pass on this cute picture. Um, so why are we in this caught up in this game of whack-a-mole so often as security professionals or security organizations? I will first say I don't know. I wish I had the concrete answer. But from my point of view, one of the things that I noticed is the law of inertia. I think it is a lot easier to not do anything and just stay operating under the status quo than it is to take action and say, I'm going to solve this class of issues once and for all, or I'm going to make sure we don't ever see this kind of alert in the future. Um, it just takes somebody taking a decisive action to solve something that has been bugging the organization or bringing down the organization for an extended period of time. And so my goal for today is threefold. I want to offer some perspectives on security whack-a-mole. Again, I've been hearing about this for a while. I've experienced this both as an IT professional and mostly as a security professional. Um, Second, I want to try to land this for the diverse local MocoSec community. This is one of those things that I really liked about local MocoSec, is that it was a conference that was incredibly diverse in many ways. And one of those ways was just you had everything from red teamers, blue teamers, you had security researchers, you have enterprise security architects, you have product security professionals, AppSec, and you also had, from junior entry level career to director level, etc. And so I really appreciated that. And even though the focus of my chat and my talk today will be on security whack-a-mole from a product security perspective, I'll do my best to try to land it for other careers and career fields that are represented, I'm sure, in this conference. And the last one is obviously share some learnings on how we have approached getting out of security whack-a-mole, and hopefully help get you out of the game yourself, or at least get you started, break that law of inertia, and get you help motivate you to get you started on this journey. So before I go dive into the examples and the stories that I have to share today, I do want to take a moment to set the background because that will be, I think, required later on. So I want to start by talking about the product security ecosystem at Microsoft. And of course, Microsoft is a very large company, and I try to simplify this into four main groups. The first one, and not in order of priority, of course, is the MSRC, or the Microsoft Security Response Center. This is the organization that I'm basically representing today. An organization that has been basically at the forefront of security response and security for 2 decades now. And the responsibility of the Security Response Center, for those of you that are product security professionals, this is basically our version of the Product Security Incident Response Team, PSIRT. And if you're familiar with the PSIRT, I'll add in that we are a hybrid model PSIRT. And you'll see that on the next group, which is a security assurance organization. At Microsoft, given that we have so many distinct product lines and so many large groups, security assurance is spread out throughout the company. And of course, these are the teams that are focused on guaranteeing and improving the security assurance of our product, working on the next version of our products and ensuring they bring the best security features possible. We also have incident response spread out through the company, just like security assurance. And this is, again, because of the nature of the products and the platforms that are supported. You can think of an Xbox Live incident being very different than a Azure Cloud or Office 365 Cloud incident. And so it made sense for us to have different incident response teams closer to the actual products or services they support. And also threat intelligence teams, again, spread out. All of those obviously work together. All those three teams work together. And also with the product groups, which are obviously where the engineers live and where products are not only worked on for new products, but also where products are maintained. So when you see vulnerabilities being reported to Microsoft, go from MSRC directly to product groups. When there's an incident that involves our company, it likely starts with an incident response team, and then MSRC gets involved at a higher level on the incident response chain. So as the organization on the product security side, we'll get to this a little bit later when I go through some of the stories. I do want to talk also, because I get asked a lot, what does a typical year look like in vulnerability response at Microsoft? And I'll start by talking about 2019 and the first step of that journey, which is submissions. We have a portal and we have an email address, and we get reports from security researchers this way, but we also get, like anybody else, a lot of spam that gets filtered out. We also get a lot of customers reporting, issues like, hey, I forgot my password. Or, hey, I'm seeing malware delivered from this IP that happens to be on Azure space, and a variety of other issues. And we take those and we route them to the appropriate place at Microsoft, or we reject, obviously, a spam with our filters. So what makes it out of that initial triage is 9,600 a year. And from there, we then evaluate, we see, okay, this is a valid vulnerability response, so we'll go ahead and take a look. And after we do that, we go ahead and create cases, which is our indication that, hey, there seems to be a valid case that there is a vulnerability in our product. And we open about 5,500 of those. And think that the things that we consider submissions versus case open, we reject things that don't meet the bar, and we know they don't meet the bar. So things like, hey, you require administrator access already in order to achieve this outcome. That's not going to meet the bar, so we reject those. We also get very incomplete information, and sometimes they never come back to us, so we end up rejecting those. But once we file these ones for investigation, 5,500 of them, then we get an engineer and we start an assessment to reproduce the issue and turn out and come up with an assessment of what the issue is. Out of those, we end up with about 4,060 last year that were unique issues, meaning they were not duplicates or they were not things that we already knew about. And out of those, 1,750 were critical or important severity. And I highlight those because it will be important for later on in the conversation. These are the ones that, from a product perspective, meaning an installable piece of software or an operating system, these are the ones that will receive a security update from Microsoft. In very rare occasions, we service things below critical or important through a security update. Those usually get fixed in the next version of the product. And for completeness, even though there's no relationship really in the funnel, is the number of unique CVEs or common vulnerability exposure, which is think of it as a unique identifier of software vulnerabilities. We issued 899 of those in the year 2019. Now, there is no direct relation to the funnel because some things that we fixed in 2019 were actually reported in 2018, and vice versa. Something that was reported in December of 2019 likely didn't get a fix until later in the year 2020. So that's what a typical year looks like. And I also, not quite a calendar year because we do this number by fiscal year. So this runs from July 1st, 2019 through June 30th, 2020. Our bounty program is incredibly active. Last year, we paid $13.7 million in bounty rewards. This was a record for us. And so I want to first say thank you if you're a researcher attending this conference and you participated in our bounty programs or have submitted issues to us. I want to thank you for doing research in our platform and thank you for working with us. And if you have not done research on our platform or taken advantage of our bounty programs, highly encourage you to take a look. We have great number of bounty programs, anything from cloud platform, obviously, to Windows and applications. So I'm sure that will be something that will be of your interest. We would love to have you do research on our platforms. So that's a typical year. And let me put that in perspective when it comes to the last 4 years. And what you see here is the same funnel, but now over a 4-year period. And as you'll see here, all of those are going up. Total cases, unique cases, critical and important, and the number of CVEs that we issue, all of those are going up. And so you might be wondering right now, why am I here talking about getting out of whack-a-mole when it seems we are not getting out of whack-a-mole. In fact, we're solving and having to issue more fixes ourselves. And so let me hopefully try to answer that over the next few minutes. So first is that the number of unique vulnerabilities found does not necessarily mean you're doing a bad job with security whack-a-mole or otherwise just doing a bad job when it comes to protecting your customers. And one of the data points that we looked to come to that conclusion is, how many of the CVEs and what percentage of the CVEs that we release are exploited within 30 days of a fix being available. And just like we also look at how many get exploited as an all day. And what you will see here on this chart is that over time, we're actually doing much better in terms of the number of CVEs that see exploitation within the first 30 days of a patch being available. You can see on the bottom there in the dark brown color how the percentage of those has continued to go down. And it's just it's not just percentage, but total numbers as well. So that gives us a really good signal about our approach to securing the platform. That yes, while we might be seeing more CVEs and more vulnerabilities, the actual risk to customers seems to be going down, which is what obviously we want to see. By the way, I selected this palette because it's supposed to be calming. The colors, I think we all need a little bit of that right now. So I hope you you like the colors that PowerPoint shows when it came to calming colors. I certainly like them. So the other thing that we look at to make sure to validate our approach to whether our mitigations and approach to getting out of whack-a-mole is working is looking at widespread attacks. And from our perspective, we see that they're now becoming the exception rather than the norm. If we take down a trip down memory lane, you'll see that in the year 2000 and early 2000s, there were a lot of server-side exploits. And from there were a lot of productivity app exploits through Office and Adobe Reader. And then browser-based exploits. Lots of them with Internet Explorer, obviously Flash, and ActiveX controls, which if you were either supporting IT in during those days, or like myself working on response to security issues in Internet Explorer, you were quite busy because we had a lot of those, and we also had challenges with obviously the usage of ActiveX. But then you look at what we have been doing on the mitigation side, which again, we look at mitigations as a way of either eliminating big class of issues or reducing the severity of issues that are indeed found. And you can take a journey also on the mitigation side and see the effects and how some things have been eliminated over time, starting with, of course, Windows XP Service Pack 2 back in 2004, which had a firewall on by default and had DEP. Windows Vista shipped with ASLR, and of course, Windows 7 then shipped and really got adoption of ASLR. Office 2010 with DEP, ASLR, and introducing the concept of protected view, which to date has been a fantastic mitigation for our customers. And then, of course, Edge shipping in 2016, which introduced, again, the sandbox, ASLR, DEP, control flow guard, as well as many other mitigations. So we have been obviously fixing a lot of things on the platform, fixing vulnerabilities that are found, but also developing new security features or new mitigations to both eliminate classes of issues as well as reduce the severity of ones that are indeed found. And I think what we see now is that widespread attacks are really now very uncommon, and not just work that we are doing in Microsoft. I think it's industry wide, of course. Pervasive sandboxing is now pervasive. Regular updates, like everybody has a concept of a up-to-date application, or at least they have a channel by which they can keep software updated. And of course, strong mitigations, not just on the Microsoft side, but across the industry, are having a real effect on minimizing the effects of vulnerabilities. Site isolation is one that I can call out on the Chrome side that I think will be on this list. I think that's a fantastic mitigation that I think in future years will help keep us ahead of other attacks. And of course, Edge now adopted Chromium, and with that, site isolation. And so a lot of good things happening, and that's not to say that exceptions will never exist. 2017 was an exception with WannaCry, and so we do expect that there will be some exceptions. But I think again, the widespread attacks will be more the exception, and are being now the exception more than the norm, like they were in the past. I joined Microsoft in 2005, and we were dealing with a lot of fires back then. And major widespread attacks. You see now things like Zero Logon, of course, seeing some activity, but again, not the widespread attack that we used to see. To say, if you're in charge of security in your company, please take a serious look at Zero Logon and consider applying secure channel and the registry key for secure channel sooner than next year. So hopefully I've built the image and made a case that even though vulnerability numbers seem to be going up, the risk to customers actually seem to indicate that is less than it had been before. So we are having some success here with regards to protecting our customers and getting away from responding to widespread attacks, which is in itself a way of doing security whack-a-mole. The other area that I would like to highlight is the root cause analysis that we do for all of these vulnerabilities that get reported. And again, if you're a defender or if you're in a SOC, you also do root cause analysis for incidents or for other events that happen. And so in this particular case, I'm applying root cause analysis to the vulnerabilities that are found. And at a high level, you can see here six different categories of issues that we have analyzed. One is just a container for other classes. But you'll see here that just like the majority of other companies, depending on their products, but cross-site scripting and memory safety issues are really the big two categories that most companies are dealing with. And certainly for us is the same. Those are the big two categories. I would like to highlight here how one of those stories about eliminating a class of issues. If you look at the 60% mark, that light blue color, those are cryptography issues. And you can see that in 2016, there were roughly about 10%. And they continue being about 10% through 2017. And then you start seeing a big line down. And essentially, they were eliminated in 2018. I say eliminated, but in reality, they were just completely reduced. And now you see every now and then you see a vulnerability pop up. Like there was one obviously earlier in January of this year regarding ECC. And so this particular case is really simple and to explain. This one was, if you go back to 2016 timeframe, there was a lot of discussion around moving unsecure traffic on the internet, HTTP traffic, to secure HTTP or HTTPS. And so back when that conversation was happening, and some announcements have been made by Chrome to highlight that and other browsers too, we started receiving a lot of reports from mainly two different finders. They were reporting a lot of Microsoft websites that were collecting information or that seemed like they should have a secure HTTP connection. And as a response function, of course, we take those reports in and we consider that a serious security issue that we should correct. And you can see that a company like Microsoft, we have a ton of websites. And I think any company that has a large sales and marketing function probably has the same issue of many websites popping up left and right. And so every time we got a report, we had to respond to, okay, let's go out and fix this. And what is this website and who owns it? And it wasn't as easy. We weren't really that prepared to handle that influx of website security issues coming up. And so we took a step back to say, hey, we can't be waiting on a finder to tell us about a website and then have a timeline to go and respond. So how do we get ahead of this and how do we solve these issues? And to condense the story and long story short, we basically did it through policy and through tooling. So implemented a policy that went down to like contracting. So anytime somebody wanted to contract to establish a new website, there needed to be a guarantee about secure connections if information was going to be collected. And we used tooling to identify websites that were not meeting that requirement. And through the year 2017, basically, both the proactive, no more insecure websites, as well as the identifying the websites and having teams provide a correction, helped us eliminate that class of issues for us as a response function. So very quick and simple example of how we eliminated a major issue, 10% of cases in the year 2016 that were coming into our response function. And again, not the kind of incident that we really want to be handling from a response point of view. We want to be handling other types of incidents. So really quick story there. But again, if you look at the big category for us, memory safety is the big problem area. and then not just for us, right? If you look at other operating system providers, especially, you will see that memory safety is a pervasive problem. So let's drill down on that for a minute and break down what exactly are those root causes within memory corruption. And one thing that you'll see here as we go through this, as you see the diagram, is that stack corruption there in the bottom from 2006 is represented close to 20% or a little over 20% of our vulnerabilities in the memory corruption space. And as we dug into the data and as we took action on preventing some of this, you will see that at this point, stack corruptions are essentially dead. And they have eliminated, and we have basically eliminated one less bug class for us to worry about. Likewise, you can see in that middle section, in the light green, you can see between 2013 and 2015, let me highlight this, in this area here, you can see a big increase in use after free. And that was a result of basically security researchers getting really, really good at finding use after freeze and exploiting use after free. And so we saw that big influx, and the team at the time decided, well, let's get ahead of this and let's work on all of these use after freeze and how we get away from having to respond to each one individually. And out of that came a mitigation called MGC, or Memory Garbage Collector, for Internet Explorer. And that essentially eliminated the use after free class for Internet Explorer. Just like that, one swipe out of that game in Internet Explorer. Again, just a dedicated team looking at the data, considering whether there was a solution that could get us away from having to respond to each one individually, and then just taking the action to pursue it. It does take time. It does take time to develop some of these mitigations that are in key areas of software, browser, or operating system. But the return is there. Once you complete them, you do them right, you eliminate a big class of issues, and you can concentrate your energy on other things. And again, the same applies in whether you're in a SOC or whether you're in TI or in some other security function. Sometimes it takes a while, but taking that time to solve a class of issues will pay dividends in the future. And frankly, will be the only way that you can keep up with new things that come up. Outside of that, the other highlight to say is that at where we were in 2018, we had 4 major classes of issues in the memory safety space. Heap corruption is still used after freeze in other places, type confusion, and uninitialized use. And so we decided to take a look. We always are taking a look at the top root causes, but uninitialized use is one that we are also seeing starting to increase in the number of reports that we were seeing. To put it in context, we had 82 in the year 2017, and we had about 61 in the year 2018. Both of those were the highest ones that we had seen up to then. So again, a team of engineers decided, okay, let's look at this problem, because uninitialized memory is a problem on its own for a couple of reasons. The first one being, it can lead to security issues, period. We have many real-world examples of exploitation of uninitialized memory, manifesting by leaking targeted data or influencing uninitialized values, leading to code execution. The other area outside of just seeing real-world influence was that when we were getting these reports, ultimately it was extremely difficult to prove whether one of these bugs actually had or did not have a security impact. It's very hard to prove the negative, just like in other areas of security. But as a software vendor, we must be conservative. And so we must fix these bugs if we cannot confidently confirm that there is not a security risk. So the outcome is that we ended up fixing a lot of bugs that we were not sure that they had a security impact. And of course, not only work for us, but ultimately this has a big impact on our customers that then have to get patches and they have to install them. And well, first they have to test them, install them. And of course, there could always be a compatibility or performance impact when we're doing fixes. And so it's a major impact, not just for us, but also in our customers. So understanding that there was a real risk, but that it was also causing a lot of churn, it seemed like another one of those efforts that we should undertake to see if we can eliminate this class of issues. And so that's exactly what one of our engineers decided to do. And I get to talk about this, but all the credit goes to the members involved in this project. MSRC, one of our engineers called Joe Bialek in the MSRC led this effort. And looking at the data and understanding the problem of uninitialized use, decided to go solve and get ahead of this. And again, there had been experiences like the use after free example that I talked about earlier, as well as many others. But this one, led by him, basically got together with the product groups, in this particular case, Windows, as well as the security assurance team within Windows. And we needed to involve another team, which was the Visual Studio team, because in this particular case, Joe had theorized that the solution would be a compiler-based solution. So he gathered a coalition here to go solve this problem. And of course, the product, as you saw in the previous chart, the product is owned by the product group, in this case, Windows. So us in MSRC, as a security function, we cannot just go in and say, okay, we're going to change a function of Windows, or we're going to change the way Windows works to solve a security issue. Ultimately, the product group is responsible. So Joe had to work with them and define kind of what is the criteria that would allow Windows to accept a change to eliminate this class of issues that is bugging not only us, but also their developers. And so I won't go into the details of every one of these criteria or considerations, because it's not the point is not the technical aspect, but rather the journey. But suffice it to say, there were some very strong requirements here from an engineering perspective. Of course, the solution needed to make sure that it will address the security problem, that it will actually make things safer. Of course, it needed to be performant. Dropping performance is highly unacceptable to many customers, as well as to the Windows as an operating system itself. Of course, it had to be compatible. We have tons of programs that depend on Windows as an operating system, and so all those existing programs need to continue working. We cannot expect programs to change or developers to go make changes. And finally, we keep Windows. We have a commitment of 10 years to Windows running. So, and it's obviously has been an operating system that has been used for a long time. So we need to be flexible. We must not paint ourselves into a corner, because we're going to live with our decisions for a very long time. And so the considerations were outlined, and the process, once the considerations were outlined, the process was basically, okay, let's find a secure solution, and let's iterate on that solution until we satisfy all of these criteria that has been set for by the product owner, in this case, again, Windows. And the solution turned out to be, as I mentioned, a compiler-based solution called init-all. Again, I won't go too much into the details of solution, because that is not the point here. But basically, the solution involved automatically initializing stack variables to 0. 0 is the safest value. And again, all of this was done through a compiler change. Now, when evaluating this class of issues, there were two big categories, if you will. One was stack memory vulnerabilities, and the other one was kernel pool vulnerabilities, all within uninitialized memory. So the problem had to first be scoped. That is a big problem, and it was split into two: stack and then kernel pool. And so the first of these solutions went live or went into our fast ring in November 2018, and then it got incorporated into the next version of Windows in 2019, April 2019. And so at this point, that has been running for well over a year. But it took about a year to get there. An effort, compiler changes. The first time Joe compiled Windows with this change, Windows wouldn't boot. And so from there, it goes into evaluating, debugging, understanding what trade-offs you need to make. And there were some trade-offs that had to be made. But so far, since this went live, we have not seen a single uninitialized memory vulnerability that has been reported to Microsoft we have not seen a single one that repros on a platform that has a init all mitigation. So great success. Unfortunately, we couldn't bring this mitigation down to all of the supported platforms. So we're still fixing some of these uninitialized memory issues. But for newer platforms, we're now completely out of that game, at least so far, knock on wood. Now, again, some trade-offs needed to be made, and work will continue specifically on this area. But so far, great results. If you're interested, we have a blog post that Joe did on May of this year. Highly recommend you check it out. And he also talks more about the journey and the changes in a CPPCon conference. You'll have a link on the slides. I mentioned that that problem was split in two. One was uninitialized stack memory. The other one is uninitialized kernel pool memory. That required a whole different solution. I'm only adding this for completeness. But after work finished on init all and that mitigation, we're continuing to this other class, kernel pool memory. And that was because, again, when we look at the data, half of the reported issues were in stack and half of them were in the pool. And so the change here, or the solution here, was basically two new APIs. That's 0 by default. And so unlike init all, this basically requires code changes in order to use these new APIs. And so we're now on that journey of moving existing Windows teams to use these new APIs. And we're also are going to work with third parties, because driver vendors, etc., can and should use these new APIs. So it's going to be a long journey, but the APIs are out since earlier this year, and you can see the tweet there about adoption, because now that the solution is completed, now it's about getting to adoption so that we can truly be out of this game. If you want to learn more about this particular solution, as well as our process, again, there's a blog that we released earlier this year. Highly recommend you read the story. It's, again, a fascinating story of engineering and working together with different parts. So if I try to land this with some practical takeaways from this experience, as well as the entire journey that I have covered up to now, I will have the six takes. First is to inventory the data you have and use partnerships to cover any gaps of data that you think you need, or data that you need in order to make some decisions about your security posture or where you want to go. Second, spend the time root causing vulnerabilities or weaknesses. This applies not only, obviously, to product security, but root causing the incidents that you end up having to drive, root causing the common alerts that you're seeing in your SOC, etc. There are no shortages of issues that us as security professionals deal with. Spend the time to root cause those issues so that you can then make decisions that would allow you to, again, get out of whack-a-mole and just basically invest your resources in the best manner. Third, use that data to find patterns, determine options that have high return on investment. It seems common sense. Just basically do it. Just basically get the data you need, spend the time root causing, which is part of the data you need, and then use that data to take action. Fourth, which I hope you saw, especially with this, with the uninitialized memory example, don't try to solve everything at once, and don't try to solve everything from the start. I think this is one of those things that, as security professionals, we tend to want to be perfectionists, or we tend to think that, oh, if I cannot solve 100% of it, then it's not worth doing it because the 80% is not good enough. Well, make sure that you make that decision based on data. Because again, we didn't solve 100% of the uninitialized memory from the start, but boy, what we did solve had a major impact on our response capability, and again, on the security posture of our customers. So it just happened to work out for us, and because we did that analysis. And again, we had to make some trade-offs that we will continue to work on, and so that 80% solution might become 100 or 99.9 very soon. And again, we didn't start with the whole problem. We broke it in two big parts and tackled the first one. And then as soon as we finished the first one, moved on to the second one. So I encourage you to try to do that. I think, again, as security professionals, I think we often talk ourselves out of taking an action because we don't consider it to be good enough, or we don't consider it to be perfect, when in reality, good enough might be enough. Next one is, have some skin in the game. I think this is also something I did early on in my career, especially, but I also see a lot of security professionals doing, whether it's product security or whether you're in TI or whether you're in an analyst in a SOC. You try to point out issues. You like to say, hey, this thing is broken. Please, you go fix it. You try to say, hey, this could be much better if you go do X. And my recommendation is that, obviously that is part of our role, and we're rightful to do it, and it's very righteous to do that. But when you can, have some skin in the game, by which I mean, don't the idea, don't just tell others what to do. Like, go take action, go be part of the solution, go do some of the work, roll your sleeves, and actually state that you will do it. This is the example again that I give that Joe did. He didn't tell Windows, hey, Windows, you need to go do this. He said, I will work on this mitigation. I just need experts that can help me, and I need to know very clearly what you need from me in order for this mitigation to go to the world. So I encourage you to do that. Like, have skin in the game, be part of the solution, not just point the problems. And lastly, carve out some time for doing some of these long-term projects. Like, most of the engineers that were involved in this particular project, as well as some of the other ones that I talked about, they had day jobs. They had things that they were responsible for. And in addition to that, they took on this very long-term project, or many of the other ones that I alluded to earlier. And so carve out some time in your schedule and in your time to pursue some of these long-term projects. And if you're a manager, please support your team members in pursuing these projects and any other passion project. I think it's something that as security professionals, again, sometimes we get too caught up on the whack-a-mole and don't invest on solving this larger class of issues that will have major returns for us. So the last story that I want to tell today is about safer systems programming languages. And for me, this is a great story about the journey that the team is pursuing. And so I'll do a quick background on safer systems, and then I will go back and talk about the journey. So first on memory safety. So most programming languages today are memory safe simply because they have some form of garbage collection. However, system level languages, which are basically the languages that I use in low level systems, like those that other software relies on, think kernel or think the networking stack, they cannot afford a heavy runtime like a garbage collector. So they're usually not memory safe. And so they depend on things like, traditional security development lifecycle, static analysis, fuzzing, code reviews, and of course, developer training to hopefully avoid them from introducing new security issues. But ultimately, the cognitive load on developers is super high. Tools are not going to be perfect. And so I think ultimately, we know this is not working. As we showed earlier, big percentages of our CVEs or our vulnerabilities are of memory safety type. And as I alluded to earlier, it's not just us. Any operating system vendor, especially, will list memory safety as one of their top issues. And so what can we do to solve this memory safety issue? Well, from our point of view, we think that where possible, software should eventually move to a completely memory-safe language. Again, it doesn't matter that it's a low-level system or not. We think it should be moving to a memory-safe language, and in our case, we think Rust is the best choice. So again, I won't spend too much time on why, but I'll highlight some of the reasons why we think Rust is the right programming language for us. First and foremost is performance and control. Rust is a highly highly performant language, very, very close to C and C++. And so that's one of our requirements for a low-level systems language. Second, has a very strong safety guarantee, unless explicitly opted out with the keyword unsafe, which I think is pretty cool. There's a very strong safety guarantee, and it's completely memory safe. Third, correctness, and this just basically means, it does, if it compiles, it works, and it does what it's supposed to do. And last but not least is the community aspect of it. Rust has a very, very strong community, which means there's tooling, there's training, there's a community for questions, and there's obviously good documentation and good libraries to complement Rust. And so as somebody as an organization that's looking to make a commitment on a major component like a programming language, and we like seeing that, it gives us confidence that we're making the right choice, and that there is a future in this language when we see that level of community development and community engagement. And so, if you want to read more again about the details of why we're choosing Rust, you'll have a link to our blog for you to check that out later. But what I really want to talk about is the journey, because I think that's what I find most interesting and frankly worth sharing in this particular case and in this talk. And that is because if you think about the endeavor that the team is undertaking here, we're basically saying Windows has been around for a very long time, using Windows C and C. Using C and C++, not Windows C, C and C++, and we're basically saying we think we need to move to a different programming language. There's millions of lines of code in Windows, and we're saying we're going to change the programming language. That's a major undertaking. Of course, if you're responsible for Windows as a product, that's not something that you're going to make that decision overnight. And you're probably going to not feel very good about making such a decision. And so the team knew and knows that this is going to be a long journey. I think the estimate is that this is probably going to be about a 10-year journey. And so how do you go and embark on a journey of such magnitude, of such long duration, with a team? And so that's what I wanted to talk about today, because again, as I have seen in my experience in security, sometimes we shy away from these projects. We shy away from embarking on journeys that are going to take multiple years. Part of it is, I think, we developed the fast twitch muscle. And so let me share this journey. I think it's super interesting, and there's some lessons that we can apply as we look into other endeavors. So first is what I will say the obvious mechanics of making any technology decision. So there's decisions that need to be made regarding cost and benefit, especially on programming languages. There's decision around tooling. Does it integrate with our current tooling, etc. There's obviously integration with the build system that needs to be considered, and then interoperations with other components, with either assembly or C or other components that might not be able to move to Rust. So anytime you're making any programming language decision, you're going to have to do these things anyway. So I don't want to diminish or state the obvious, but those things are obviously part of the journey and the conversation, just like any other security project. For this particular journey, though, I think both the specificity of it, meaning programming language, but also the fact that it's going to have such a long duration, finding enthusiasts inside the company is absolutely critical, and building partnerships with them. And this is about generating momentum, and I call it the snowball effect. It's about trying to get enough people excited that snowball picks up steam and volume, and eventually is just moving through eternity. Well, snowballs, but that aside, next is join the international community. Participate, contribute, get a good sense of what that community is like, where the direction of the community, direction of the tooling, documentation, training, etc. And participate, like state your goal, and recruit people to help and to offer their perspective. So first find enthusiasts inside of your company, then move externally to other groups, and then just start. Like, again, law of inertia. First, Newton's first law of motion. Sorry. Just start somewhere. Pick up that momentum. Jump off that mountain with skis. And so you'll see we did. I'm going to talk about some of the things that we did publicly and some of the things that we of how the journey started. But again, finding those enthusiasts in the company, it all started with a few engineers that were really enthusiastic about Rust and were already playing with Rust in their free time. And so they started, making noise and talking about Rust as an option for Microsoft. And from there, they started making a case. Enough people got interested, and then projects started popping up from the enthusiast community, as well as a deliberate effort to answer some of the questions in that first bullet. Is can we make this work with our tooling? What will be the effect on our build system, etc.? And so the first thing, we had a couple interns working on Rust, and so you can read about the experience of the intern, of the two interns. One basically designed a COM library in Rust, and so we learn from their experiences. We also get the perspective of somebody that's basically picking it up for the first time, so that we can then translate that into developers in our company at taking a new language for the first time. And then start finding again those enthusiasts and those projects that you might be able to do. Like in this particular case, building the security daemon for Azure IoT Edge in Rust, a critical component, but of a small product. Second, another one is do an experimental rewrite of a low-level component of Windows. See what the learning is. See what the impact will be on the Windows side. Again, this is translate that to whatever it means in your organization. But this is the big one for us. And so start with a low level project and as an experiment, and go and do it and see what the learnings are out of that. Then move to other parts of the company, like Azure IoT Edge adopted this. Experimental reader in Windows and other projects that are ongoing. Use Rust in a cloud component. See what the implications are there and how it would affect, again, some of those things in the first bullet here. And next, the last one we did is making a platform security technology, control flow guard, into or make it available in Rust. Again, if you have platform security technologies that depend on the compiler or the programming language, make them available and see what that will entail. And so, whatever project you're contemplating, think that you're going to need. If it's a major project, you're going to need many different teams involved. Get something going. Start a project with any of those groups or with all of them, and start small. Start experimenting. Start doing a small project so that you can get that ball running. And I'll finalize saying all of those, as you see in the presentation, are links to active blogs or to published blogs that talk about the project as well as the experience. Again, all of these are experiments. We have many other experiments ongoing throughout Microsoft, and you can be sure that we will be talking about those in the same MSRC blog. So I highly encourage you, if you're interested not just in Rust, but also in kind of following the journey, just follow the blog. We'll be posting there. Again, this will be a 10-year journey. This might be a 20-year journey. But imagine a future in which that big class of security issues that we see in the bottom, memory safety, is completely eliminated. That's what we're talking about doing here, is the ultimate eliminator of whack-a-mole for something that has been plaguing us for many, many years, plaguing us and plaguing our customers, and many others in the industry. So I hope that we are able to succeed here, and I hope that we're able to use that as an example for also others to kind of join in on the same effort. So it's definitely a journey, and it's definitely a future worth pursuing. And so that is the end of my presentation. Happy to have a conversation anytime. You can reach me. That's my Twitter handle. I want to finalize by saying thank you again for allowing me to present again. I had a blast when I went to Local Moco Sec last year. I was really looking forward to this year. But I have been able to watch a lot of the presentations, and I'm excited that we were still able to do it and get some great content. So mahalo, and open to any questions or dialogue after this presentation. And thank you, and stay safe.
Close out Locomoco Sec, George, especially on the Locomoco Sec vibe of practical defense and product security advice and just lessons there. The first question that I think you answered pretty thoroughly, but I'll just leave it there if you want to be a little bit more concise. It's most of the security issues you have described are caused by the use of memory unsafe programming languages. What is Microsoft's progress in migrating to something like Rust? I know you kind of touched on it, but I didn't know if you just wanted to summarize, like, hey, here's where we are, and just that last few points you made.
There is no decision, I guess, is the way that I will describe it. There's no decision made. We continue to experiment. It continues to get adoption. You're seeing it on some production level code, and so I think we are well on our journey. But it's going to be a long journey, and we knew that from the start.
Okay. And in the earlier part of your talk, you discussed, you had a nice visual of all the different vulnerabilities that you guys had and how you were kind of seeing it increase, but there were some efforts where you were seeing less of certain ones. But as Microsoft's bug bounty program, continues to reach new heights and you guys are getting more researchers on that platform, have you guys seen that you are addressing more of the same type of severe bugs? Like, I don't know, is that factored into some of the analysis that you guys have done?
Yes. When we see some of the same bugs and the same type of issues is when we go into that journey of what can we do to get out of this class of issues. And so one is we see a lot of innovation through the bounty program. So this is not to say we get only the same type. There's an incredibly diverse group of researchers. So we do get an incredibly diverse set of issues. But every now and then, something clicks in the community, and it clicks at the same time. And then all of a sudden, you get a whole slew of the same class of issues. One example was issues related to time of check, talk to issues, time of check, time of use issues, and sim links, hard links, junctions that James Forshaw made popular. James Forshaw from Google Project Zero. And then another researcher called Sandbox Escaper picked up on that research and then did more research and found a number. And through her write-ups, other researchers started doing research and found more. And so you have this effect where now every now and then you get this influx of the similar kind of issues because somebody had a discovery that triggered many other researchers into doing their own research and with their own expertise, and you end up with this incredibly diverse but very focused specific class of issues. And so we do see that happen. It ebbs and flows, and obviously that's a very strong signal for us, just like the example I gave with use after free in Internet Explorer. But that's a very strong signal for us to go focus on the class of issues, so that we're not caught up having to respond to these individual issues for a long time.
And so next question, we heard from Asa Singhal earlier today from Netflix around product security lessons from incident response. Now, looking at the makeup of Microsoft's team and how you guys have your teams sorted out there, how do you guys factor in like the lessons from incident information specifically? I know you said like the widespread issues you guys have kind of had an analysis on, maybe like more pinpointed ones. How do you guys then factor that into the process for then addressing the security whack-a-mole?
Yeah, great question. I'm sad that I missed that presentation. I'll have to catch the recording. So it's basically a continuous loop, and it's a continuous feedback loop where thing that we take different signals in how we analyze data. One of the signals that I talked about today was specifically security researchers finding vulnerabilities in Windows, and I showed data around that. The incident response side is very interesting because, again, there's different kinds of incidents. Some of it are related to vulnerabilities. Some of them are related to other issues like misconfigurations, etc. And so we do try to have that close feedback loop of what is driving incidents, both for us as well as for our customers, and what is the root cause of those incidents, and then how do we, and then feeding that, not how, but feeding that back into the product engineering teams so that they factor that into their planning for new features or for things that need to be addressed. One example of that could be, again, the example of misconfigurations. Maybe it's not the customer's fault that they are configuring something one way. Maybe we should consider changing the default. Maybe we should make it more obvious what the configuration, what the effect of the configuration is. And so we take that signal from incidents and pass it on to the product engineering team with a, hey, this is causing pain to our customers. It's causing incidents, and then they can evaluate what action to take. I hope that answered the question.
I believe it does, and if not, again, I believe you've made your social and email or contact available so people can continue to reach out and have the conversation with you from there. But George, thank you very much. Mahalo and aloha, and hope to see you in Hawaii in the near future. Please take care.
Thank you so much.